given how your presentation is laid out, do you prefer to have questions during, or would you rather have the committee hold them to the end? It's really your choice.
Basically, what I'm going to do is I'm going to just kind of give an overview of what we do.
Okay.
When we get samples from the BLM, kind of how we do things. I'll give a little summary at the end. I'll give a little summary at the end. Is that okay?
Yeah.
In terms of overall variability, things like that, which Dean discussed a lot. Dean said things that probably could have added about an hour and a half to my talk. Topics that I hadn't even thought about, but which we have thought about and discussed before. Questions anytime are fine.
Okay. All right. Thank you very much.
Okay, so this is me. I'm at the Texas A&M University now. I've been there almost 6 years now. Before that, as many of you know, I was at the University of Kentucky. I started working with horses in 1982. Before that, I'd done work in natural populations of wild rodents and white-tailed deer, and a few other things. But in 1986, I went to the University of Kentucky, and within about 2 years, we were involved in the study of wild horses on the East Coast, on some of the barrier islands. That led to an individual who was involved with adopted Mustangs, or Mustangs that people had gotten from various sources before the BLM's adoption program, but now we're in private hands, contacting me and interested in genetic testing of some of these other horses. And that eventually led to testing of the BLM horses. And really, I think we maybe did our first test of a BLM herd either in 90 or 91. I can't remember exactly. The Pryor Mountains herd was one of the first ones. Also I'm forgetting the right name for the herd, the one up in the Grand Junction area. Those were some of the earliest, and they were actually private individuals that managed to get samples to us. But eventually we had some of the horse specialists at various BLM sites contact us. They were interested in maybe having some of the genetic analysis done on their population of horses. And that finally led to a fairly, well actually now a fairly formal association and a very routine method of reporting the results to the BLM and repeating things on a very regular basis. Initially, when we started, we were using blood group markers and biochemical genetic markers. So we were not testing DNA, we were testing gene products. However, this was very effective. This is what was being used for parentage analysis, for horse registration. Many population genetic studies of horses were done all over the world using these kinds of marker systems. Also, the information supplied from the BLM was very variable at that time. It's become more standardized, although still different people at various sites provide more information. I will say, and this is kind of typical of what we do now, you maybe can't see that very well, but that gives the location of the HMA, the herd management area, lists the individual samples, the color of the horse, the sex of the horse. Sometimes, this one doesn't have but just one horse that they had an age on. Oftentimes they will have age information. That's something that can be very useful, although in most cases the population sizes are too small for us to really make much use of that particular information. So we tested 17 genetic marker systems, or loci. Sample sizes vary, but usually we're between 25 to 75. We calculated standard measures of genetic variability. These values were compared to those of domestic horses, for which we had a little bit more information about perhaps what the level of inbreeding within that domestic breed was, whether there were genetic problems associated with that particular breed, population size of the breed. We had that kind of information, and that was very important because this is all, at this point, comparative genetics, because we do not really have any kind of experimental data on horses that could say that this particular level of heterozygosity or variability is okay and this one is dangerous. But by knowing something about all of these different populations, we can make some educated guesses on where the genetic health of a particular population stands based upon this kind of information. So that's a little hard to see, but basically we could give the populations, and this is several herds from Wyoming that are given here. Notice this herd was had 2 different sample times. We give some standard measures. This is observed heterozygosity, expected Hardy-Weinberg heterozygosity, estimating inbreeding level, affected number of alleles, and total number of alleles. So these are measures of individual, population diversity measures. Observed heterozygosity is something of an individual variability measure. We tested all of these things across a large number of populations. You notice we have some mean values here. At that time, we had tested 54 feral populations and 118 different domestic breeds. So these are not sample size, these are the number of breeds for the means. So, one thing I'll get into a little bit later is one of the most useful things from the management standpoint is once you've tested a population a second or a third time, because then you can actually see whether changes are taking place, whether the management itself, in terms of mainly population size, are having effects on diversity levels. But you can see here we tested the 15-mile herd in 1991 and again in 2000, and the diversity actually went up in that time period. I did not have any information to explain that. There was and actually the sample size was smaller the second time, so possibly there had been an introduction of animals or a adjoining area had connected to that herd so that there was now gene flow and increasing the diversity. Again, we have some various domestic breeds. Notice that the domestic horse mean, and for the blood proteins, I usually focus on the observed heterozygosity as being the most informative measure. One of the things is that in horses at least, never looked at it anywhere else, but in horses, observed heterozygosity is independent of sample size, whereas all of these other measures are related to sample size. But anyway, notice the domestic horses are slightly higher on average. That's not maintained so much once we get to the DNA. Good range of variability here from the thoroughbred, which even though it's a very large population size, it's been a closed population for about 400 years, starting from a relatively small number of individuals. And it is one of the lowest levels of variability within a domestic breed, whereas you have breeds like the American saddlebred or the Peruvian Paso. These are extremely variable breeds. We also calculated coefficients related to relationship to the domestic breeds, because there was interest in the origins of these populations. And again, we compared these to generally a standard set of domestic breeds that represented the kind of horses that were likely to be in the United States at the time feral horses might have occurred, but also some European breeds and things like that contributed to the origins of many of the domestic breeds in the U.S. We also sometimes, depending on the state and depending on how many different HMAs we had tested, we also will compare the HMAs among states when we have within a state, and we give a dendrogram or tree diagram for each of these types of analysis to kind of give a pictorial, two-dimensional representation. So we do a comparison to the groups of domestic breeds. This is like what includes the thoroughbred. This is the Arabian and some others. Horses from Spain and Portugal, horses from South America, or North America and the Caribbean, but of Iberian origins. These are breeds that were developed in the United States, such as the quarter horse, the saddlebred, standardbred. The heavy draft breeds, like the Belgian draft, the Suffolk, and the true pony breeds, like the Shetland, Exmoor, some other things. I tend to report a coefficient called Rogers similarity. That's not used very much anymore, although it did have a lot of use in the early days of biochemical genetics. The reason I use that is, first of all of the different genetic similarity or distance measures are very highly correlated with each other. So you still get basically the same information if you use NAS similarity or Rogers similarity or NAS similarity or one of these others. But this one is reported as a value that approximates the percentage of similarity across the variants tested. And so this one is more intuitive for someone who wonders what a value of 0.031 for a genetic distance might mean. Okay, so this is the reason I tend to report this thing, this coefficient. And so this tells us kind of, because most of the horse breeds, or most of the wild horse populations are mixed origins, it can be very difficult to determine if a particular breed, in many cases, contributed directly to the origin of that herd. But sometimes if you just look at kind of the general similarity, you can see that perhaps this herd was influenced either by Iberian or draft horse. And we do know that there's a bit of draft horse history in the McCulloch Peak area. And so this is a simple dendrogram. What you see here is what we often see is that the feral herd does not show close relationship to any of the domestic breeds. That's the only point for this particular thing, looking at it really quickly. Sorry, these don't come out better, but I was doing a bit of cutting and pasting on these. And from old reports. And this is, again, this is because primarily of the mixed origins of the herd from various different kinds of domestic breeds or even non-breed domestic horses that were brought into a region and released. Or it also can reflect the demographic history of the population, being isolated, small numbers or fluctuating numbers. So there are a lot of things that enter into these. And again, this is just showing that we do this for various HMAs within a state. This is usually a request from the particular HMA.